Students, good morning. Yesterday, I gave one video that is a matrix, that is 10th part. In that video, I taught the definition of symmetric matrix and skew symmetric matrix and two theorems, important theorems. Those definitions and theorems are important. Those questions are asked previously, yeah. But in that last video, previous video, I used a whiteboard. It is somewhat smaller, this board. It is giving some problem to me. And it may be a slightly a disturbance for you. Some glaring is formed in that board. But in that light shade, no numbers or any steps are there. So no need to worry. You try to follow it a number of times. It's simply the definition of symmetric and skew symmetric. And some examples given. And two theorems are given. Okay, na? Only that is 29 minutes. It's a 30 minutes video. We try to take it now. Okay, Nana? Now this is an example, 22 example, and then we'll go to the third exercise. This is an important problem. It is also dated. It is asked in the previous exam. You see, the matrix B, it is a given matrix. This matrix is asked to express as the sum of symmetric and skew symmetric matrix. Again, the second theorem is there. With the proof, I solved it. Here also, by using that theorem, we have to prove, we have to show, we have to express the given matrix capital B into sum of two matrices. One is symmetric and another is skew symmetric. Such a manner we have to express it. Now you see, this is a solution. Observing given, what is given? Capital B is equal to 2 minus 2 minus 4. Minus 1, 3, 4, 1 minus 2 and minus 3. Okay, now this is a 3 by 3 matrix. Now we find B transpose. You know it well. Transpose means simply you change the rows into column. Rows into column. Okay, now this is the transpose of the given matrix. The first row becomes as first column. The second row as second column. The third row as a third column. Okay, now this is B transpose. Okay, now let capital P is equal. We are assuming, we are considering P is equal to 1 by 2 into B plus B transpose. Okay, now that is equal to 1 by 2 into what is B? We are given it is 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3 plus and B transpose. B transpose is 2 minus 1, 1, minus 2, 3, minus 2, and minus 4, 4, and it is minus 3. Okay, now? Say, this is the B transpose. Okay, now? And this is B. Now it is 1 by 2 into, this is addition of two matrices. How can we add the two matrices? Means Take the addition of corresponding elements. 2 plus 2 is 4. Minus 2 minus 1 is minus 3. Minus 4 plus 1 is again minus 3. 1 minus 2 minus 3. 3 plus 3 6. 4 minus 2 is 2. 1 minus 4 is minus 3. Minus 2 plus 4 is 2. Minus 3 is minus 6. Okay now? Okay now? See, first we are given the matrix B, and we find the B transpose, and we consider a new matrix, that is P, capital P, which is a half of B plus B transpose. B plus B transpose is made to addition, and now we are multiplying each and every element of this matrix by 1 by 2. 1 by 2 into 4 is 2. This is minus 3 by 2. It is also minus 3 by 2. It is minus 3 by 2. It is 6 into 1 by 2 is 3. 1 by 2 into 2 is 1. Okay now? And here it is minus 3 by 2. Again it is 1. Again it is minus 3. Okay now? You have to follow it. After adding the two B and B transpose, we get one matrix, and each element is multiplied with a constant 1 by 2. 4 into 1 by 2, 4 by 2 is 2. Minus 3 by 2, minus 3 by 2, like that. Here minus 3 by 2, it is 6 by 2, 3. 2 by 2 is 1, like that we complete. You see here, this is P. Yeah, okay. Now, observe. Observe. Here, what is P dash? P is known. What is P dash? P dash means P transpose. We say P transpose. The transpose of the matrix P. The first row becomes as first column. Okay now? And the second row is just like the second column. And the third row is third column. Okay now? Now, what you see then? It is also P now. It is same as. No change at all. All the elements, even though the rows and the columns are changed, we get again the same P. Okay now? So, P, what we consider is symmetric. Is a symmetric. Will you agree? Is a symmetric matrix. Okay now? Similarly we find, let the 2 is 1 by 2 into B minus B dash. You put a flower bracket. It is a flower bracket. That is equal to 1 by 2. Okay, Nana? 1 by 2. It is, what is the first B? B is 2 minus 2 minus 4 minus 1, 3, 4, 1 minus 2 minus 3. Okay, now? Minus is there. First I take B plus B transpose. Here B minus B transpose. And what is B transpose? This one. It is 2 minus 1, 1. Minus 2, 3, minus 2. It is minus 4, 4, minus 3. Okay now? Okay. Now this is 1 by 2. Here it is a difference. You see that? 2 minus 2 is 0. Minus 2 minus of minus 1 plus 1. Minus 2 plus 1 is minus 1. Okay na? Minus 4 minus 1. It is minus 5. Be careful. Minus 1 minus of minus 2. Minus 1 plus 2 is 1. 3 minus 3 is 0. 4 minus of minus 2. 4 plus 2 is 6. Okay na? 1 minus of minus 4 is 5. Because 1 plus 4 is 5. Again minus 2 minus 4 minus 6. Minus 3 minus of minus 3 plus it is 0. Okay na? And again it is you see this 1 by 2 is multiply each and every element of the matrix. 0 and 1 by 2 is 0. It is minus 1 by 2 1 by 2 into minus 1 minus 1 by 2. This is minus 5 by 2. It is also 1 by 2. It is 0 and it is 3. And here it is 5 by 2. It is 5 by 2 now. And it is minus 3 and it is also 0. Okay na? You see there. So Q is this one. We know Q is equal to at last, therefore Q is equal to 0 minus 1 by 2 minus 5 by 2. Okay na? It is 1 by 2, 0, 3. And it is 5 by 2 minus 3 and 0. Okay na? Easily we can say it is skew symmetric. Means the elements of diagonal, the principal diagonal, the first diagonal elements are zeros. And here the numbers minus 1 by 2, but here it is 1 by 2. Okay na? The position is row, column. Second row, first row, second column. This is second row, first column. Only the minus is there. Here also minus 5 by 2 plus 5 by 2. Here 3, this is minus 3. The elements are. So simply we may say is it is nothing but it is minus Q transpose. We will get the Q transpose. Okay, leave it out. Or otherwise, which is skew symmetric. Not needed to prove like this. Like this here, in order to make you to understand well, I find P transpose and it is P, so it is symmetric, just like. But it is not needed, simply you do. So it is skew symmetric. It is skew symmetric. Okay na? Symmetric matrix. Okay na? Okay. So we find P, that is 1 by 2 of B plus B transpose, and Q 1 by 2 of B minus B transpose. Yeah. So these are P and Q. Now see, now what is P plus Q? We will solve it. P is, it is 2 minus 3 by 2 to minus 3 by 2. And it is minus 3 by 2, it is 3 and 1. It is minus 3 by 2 and it is 1, this is minus 3. Okay now? Plus, what is Q? What is Q? Q is 0 minus 1 by 2 minus 5 by 2. It is also 1 by 2, 0, 3. And it is 5 by 2 minus 3 and 0. Okay now? We will make it addition. 2 plus 0 is 2. Minus 3 by 2 minus 1 by 2. Minus 3 by 2 minus 1 by 2 is there. I will solve here. Just observe it. It is minus 3 by 2 minus 1 by 2. Minus 4 by 2 now. That is minus 2 now. So it is a minus 2. Minus 3 by 2 minus 5 by 2. Minus 3 by 2 minus 5 by 2. Next. It is nothing but by 2 it is minus 3 minus 5. Minus 8 by 2 is minus 4. So it is minus 4. Okay. Now minus 3 by 2 plus 1 by 2. Minus 3 by 2 plus 1 by 2. It is minus 3 plus 1. Minus 2 by 2. It is minus 1. So it is minus 1. 3 plus 0 is 3. 1 plus 3 is 4. Minus 3 by 2 plus 5 by 2. Minus 3 by 2 plus 5 by 2. Minus 3 plus 5. 2 by 2 is 1. And 1 plus minus 3. 1 minus 3 is minus 2. Minus 3 plus 0 is minus 3. Okay now? Now what is this? The addition of P plus 2. We get one matrix. You see the given matrix 2 minus 2 minus 4. Okay now? Minus 1 3 4. Okay now, correct? 1 minus 2 minus 3. So this is nothing but a given matrix B. Okay now? So the given matrix, that means any square matrix, can be expressed as the sum of two matrices P plus 2. Okay now? Where P is symmetric and Q is skew symmetric. So that is okay. Okay now? It's a very important problem. Try to learn it. 1 or 2 times you go through it. Yeah. Okay. Now we are going to solve the third exercise. 4 problems are given there and we solve them. Listen and observe. Number 1. In exercise 3.3, first one. Find the transpose of each of the following. You are given, suppose let A is equal to, it is 5, 1 by 2 and minus 1. We assume. Then, what is A transpose? We are asked transpose of each of the matrix. A transpose is, first you write like this. You write like this. It is A transpose. So it is 3 by 1. And the transpose is 1 by 3. This column will be changed as a row. Okay now? That is A transpose. And number 2 is let B is equal to 1 minus 1, 2, 3. It is 2 by 2 matrix. Then B transpose is 1 minus 1, 2, 3 transpose. We can write like that also. And it is equal to, the row will be changed as the column. The second row will be changed as the second column. Without mentioning this notation, directly we may write it. B transpose is, the row will become as column. The second row, second column. Like that also we can write. The third one, let capital C is 3 by 3 matrix, minus 1, 5, 6. Root 3, 5, 6. This is 3, 2, 3, minus 1. It is a 3 by 3 matrix. Now C transpose, C dash. That is directly I am writing, not like this. The first row will become as first column. The second row will become as the second column. Third row will become as the third column. Okay now? So this is a transposes. A transpose, B transpose, C transpose. Okay, like this. Yeah. Next, we go to okay now The second problem. We are given two matrices 3 by 3 and 3 by 3, A and B. Then we have to verify that this type of questions are important. Okay, now? And we verify that A plus B whole transpose is equal to A transpose and B transpose. There also A minus B whole transpose is equal to A transpose minus B transpose. We are given, it is given capital A is equal to minus 1, 1, 3. Minus 1, 2, yeah, minus 1, 2, 3. 5, 7, 9. It is minus 2, 1, 1. Minus 2 is there, yeah. And what is it B? Is also minus 4, 1, minus 5. 1, 2, 0. 1, 3, minus 1. 1, 3, 1. Okay, na? Yeah. And first, what are the needed expressions? We have to first find A transpose. A dash or A transpose, both are same. Directly then, directly I am writing. The row become as column. The second row become as second. 1, 1. Okay, now? And B transpose also. The first row as first column. The second row is the second column. The third row is the third column. Yeah, okay now? Like this. Okay now, you see there. Minus 4, 1, minus 5. Like this. 1, 2, 0, 1, 2, 0. 1, 3, 1 as a column. A plus B. What is A plus B? A is minus 1, 2, 3. 5, 7, 9. Minus 2, 1, 1. And what is B? Minus 4, 1, minus 5. 1, 2, 0. 1, 3, 1. Okay, now? You add it. The corresponding elements to be added. Minus 1, minus 4, minus 5. 2 plus 1, 3. 3 plus minus 5. 3 minus 5 is minus 2. 5 plus 1 is 6. 7 plus 2 is 9. 9 plus 0 is 9. Okay, now? You verify once again. 5 plus 1 is 6. 7 plus 2, 9. 9 plus 0 is 9. Minus 2 plus 1. Minus 1. 1 plus 3 is 4. 1 plus 1 is 2. This is A plus B. Okay, now see there. Once again. The arithmetic is very typical one. No one is a master in arithmetic. Be careful. Minus 1, minus 4. Minus 5, 2, plus 1, 3. 3, minus 5, minus 2. Yes, okay. Right. Again, we find A minus B also. What is A minus B? Same. This is minus 1, 2, 3. 5, 7, 9. Minus 2, 1, 1. Minus, it is minus 4. 1, minus 5. 1, 2, 0. 1, 3, 1. It is minus 1, minus half, minus 4. Minus 1 plus 4 is 3. 2 minus 1 is 1. 3 minus half, minus 5. 3 plus 5 is 8. Okay, na? 5 minus 1, 4. 7 minus 2, 5. 9 minus 0, 9. Minus 2 minus 1, minus 3. 1 minus 3, minus 2. 1 minus 1 is 0. Once again you will fail, whether it is correct or not. Minus 1, minus minus plus 4. 4 minus 1 is 3. 2 minus 1 is 1. 3 minus minus 5 is 8. 5 minus 1 4. 7 minus 2 is 5. 9 minus 0 is 8. Minus 2 1. Minus 3. 1 minus 3. Minus 2. 1 minus 1 is 0. Yes, okay. So A plus B and A minus B, A transpose, B transpose, everything is Okay. Now, just, okay then, everything is there. Now, I arrange the first problem. And this one also is already is there. So we have to verify. We have to verify this one. Verify A plus B all transpose. Okay. Please observe it. Here A plus B. Not A plus B. A transpose plus B transpose. Next I am taking. A transpose plus B transpose is A transpose is minus 1, 5, minus 2, 2, 7, 1, 3, 9, 1. And B transpose is minus 4, 1, 1, 1, 2, 3, minus 5, 0, 1. What is its answer? Addition. Minus 1 plus minus 4, minus 5. 5 plus 1, 6, minus 2 plus 1, minus 2 plus 1, 3, 7 plus 2, 9, 1 plus 3, 4, 3 plus minus 5, 3 minus 5 is minus 2. This is 9, 0 is 9, 1 plus 1 is 2. Once again you verify whether it is correct or not. Minus 1, minus 5, minus 5, minus 4, minus 1. 5 plus 1 is 6. Minus 2 plus 1, minus 1. 2 plus 1, 3. This is 9 and 4. Yeah, okay. Now, similarly, A transpose minus B transpose. The 1, 5, minus 2, 2, 7, 1, and 3, 9, 1. Minus 4, 1, 1, 1, 2, 3, minus 5, 0, 1. Here also we are making the difference. Be careful. Same, A transpose B. There it is addition, here is minus 1. Minus 1 minus 4. Minus 1 plus 4. This is 3. 5 minus 1, 4. Okay now? Minus 2 minus 1. Minus 3 na? 2 minus 1. 1 na? 7 minus 2. 5 na? 1 minus 3 is minus 2. 9 minus of minus 5 plus 5. 9 plus 5 is 8. 9 minus 0 is 9. 1 minus 1 is 0. Okay, Nana? Yeah. Now, your thing is, you see the way of the solution you observe me. What we needed, you see, A plus B is needed. So we found A plus B. A minus B is also needed, yeah. And A transpose B transpose is needed. And again A transpose plus B transpose is also there. Everything is general. Now we go to prove it. Okay, now I erase this one also. Please observe me. Now the first one is, you know it well. What is first one? I will take number 1 and LHS. What is LHS? There is it is A plus B whole transpose. Whole dash is given, whole transpose you assume. What is A plus B? A plus B is this one. It is minus 1, 2 and it is minus 5, 3, minus 2, 6, 9, 9, minus 1, 4 and 2, whole transpose. There is only A plus B done. A plus this matrix. I am writing this matrix with the transpose also notation. So transpose means, you know which one. What is transpose? The row will become as a column. The second row will become as a second column. And it is minus 1 for it is 2. Okay now? So For the first one, in the second problem, first problem, A plus B whole transpose as LHS. And is it equal to this one? You see that? See, minus 5, 3, minus 2 is there. 6, 9, 9, 6, 9, 9. Minus 1, 4, 2. Okay now, what is this? This is nothing but A transpose plus B transpose. Okay now, like that we have to prove. This is nothing but RHS. Okay now, right. Similarly, you solve that one. A minus B is there. I will write here. You see there, for the second problem, LHS is A minus B whole transpose. What is A minus B? A minus B is there. 3, 1, 8, 4, 5, 9, and minus 3, minus 2, 0. Okay now? This is whole transpose is there. We may write this notation also. For the matrix at the top right side, T. That means transpose. This row will become as column and second column, and it is a third column. Okay now? You see there. Okay now? This is A minus B whole transpose. You see there now? This is nothing but that one. A transpose minus B transpose 3, 4 minus 3 is there. 1, 5 minus 2 na. 8, 9, 0 is there. Yeah. So this is nothing but A transpose minus B transpose. That is nothing but RHS. Okay now. So two problems are solved. Okay now? Plus.